So, I'm gonna go over what we've been doing in class for our drone competition. So essentially what a drone competition is, in case you didn't see the other video on my website, was it was going to be a competition where we are trying to code drones in order to fly through the hula hoops. This seems pretty simple, except for the fact that we have to figure out all the syntax of the code, figure out the direct coordinates we need it to go, and the measurements and everything, without actually measuring anything. So it's just a process of testing, running it back, changing stuff, testing, running it back, changing stuff, until we get something that's adequate enough for our measures. And so you can actually see right now, I will also have the SDK pulled up in a second. So you can kind of see the SDK. But this isn't perfectly displayed to you how we're actually provided the syntax of the code. So the actual syntax of the code is going to be using PyCharm. You can see that it's send message, parentheses, quotation marks, and then listing off what it said before. This gets slightly more muddled the further we go on, and it has more problems with syntax the more we go on. However, just displaying the overall simplicity of this manual compared to the fact that it doesn't fully line up with the code kind of lays the basis for all of the problems that we've had while actually working on the drone comp. So now I showed you that, we can go back and let's look at GitKraken. So in case you don't know what GitKraken is, it's essentially a beautiful kind of backup service in a way that will help you back up and publish your code. So that way you can actually have a really nice way of running back to any other version in case you screw something up and your code is completely broken now and you just need a way of it working again. So you can actually see from over 2 months ago is our first time we ever worked on it, and then we ended up taking a break for winter break, etc., and then we ended up coming back to it. So you can end up seeing my initial commit doesn't really have anything other than the README. Afterwards, I added the SDK and Tello template. So the Tello template is pretty much showing us exactly what we need to end up getting it running by itself. You can end up seeing I copied the template from Mr. Lang and everything, but you can see host, port, the local address to make sure that you actually get the Tello Drone's address, and then the rest of this stuff is mostly just things that end up putting it in communication with the drone. So that way it ends up sending all the messages in the code that we need for it. So anyways, after that, you can see that we added a square. We added the exact same square, except now we're using a for loop for it. Afterwards, we end up figuring out how to use a function to be able to call it easily. And then I ended up creating by myself a hexagon function that uses for loops in order to consistently repeat it. However, this isn't quite the topic of what I'm trying to talk about today. I want to talk about the drone comp. So you can see here, this was the first time that the drone comp was initialized. It essentially just was the Tello template copied and pasted. But here's where it gets a little bit more interesting. We end up getting the first hoop. So if we look at the drone comp, you can actually end up seeing that we started working on things. You can see the sleep message, which ends up going in between. It ends up just allowing the drone time to think through everything and make sure that all the processes are executed correctly. We ended up changing that to be a little bit longer because we ended up finding that it wasn't long enough for us, or every single time the drone ended up just not fully working for some reason or another. Now, because of the time beforehand, my partner already had some code working on the first tube, which we ended up working on altering because it ended up moving too close to the top rim of it, and it was a little bit further than we would have liked it to be. So we changed that to be a little bit more of an acceptable one for us, and then we continued on to the second hoop. Now the second hoop isn't as complex, but in the first hoop what we did was we said go up, go forward. So that way it did one and then it executed the other and it worked fine. But this time we don't want it to execute one and then the other, we want it to execute both at once. So we end up using a go command with multiple different coordinates in order to ensure that it goes where we want it to. So you can actually see here, this is the 240 in order to make it actually go forward, 55 to make it continuously go up, so that way it actually makes it through the hoop, and I believe the 80 should be just the speed that's set of it, so that way it goes a little bit faster. Now, the other hoop is where we started to have problems. The other hoop we were supposed to do a yaw, which is essentially just a fancy word for a circle, or like a semicircle. So we just needed it to curve essentially. And we had a lot of problems with it. The syntax wasn't very specific because of how finicky circles can be and the coordinates of them can be. It was really hard to be able to actually figure out all of this. So we ended up seeing, if you can see here, figuring it out just by Googling it. We brute force tested it a bit. We found out like a kind of way it worked, but it wasn't curving the correct way. So we ended up Googling it because we tried adding negative numbers, but we couldn't make it curve the right way still. So we Googled it. We found this code that actually ends up running perfectly. It actually goes the way we want it to and everything. So we copied and pasted this as our kind of baseline format. So this is what I mean by drone successfully curving. In no means did we even really think about the third hoop at this point. So then the work in progress for the third hoop. It's kind of our first attempt at putting in the actual coordinates and getting it as close as we can. You can end up seeing that we changed a lot of the code. We changed this from -25 to 50. We changed this from 25 to 475. We changed the speed to be a little bit faster so that way we weren't waiting there all day. But now you can end up seeing our finished result, which was essentially just us, well, our close to finished result. It ended up leaving us this, where we ended up curving. You can see that we changed it a bit. We changed this coordinate by over 60. We ended up adding 30 here, changing this by 25, changing this by 30. A lot of just little tweaks that made it significantly closer to the hoop overall. The speed still stayed the same, however. Now you might be wondering what this hashtag code is and why it looks a little bit different. This code was originally intended as a kind of backup for us if we were messing around with the code and it just kind of started not working as well, or if it went further away. We just copy and paste this back in. So that way we didn't really have to worry about it or worry about messing anything up. Afterwards, we ended up getting it to a point where it was in front of the hoop. Not as close as we wanted it to be, unfortunately, because of some inconsistencies with the drone and how far it ended up flying out. Sometimes it would fly out really far, sometimes it would fly perfectly. It just kind of depended on the time. Tello drones can be a little bit finicky in that regard, and rightfully so. So anyways, we have the send message to turn it clockwise 180 degrees, essentially just spinning it around to the other hoop since it was facing the other way this entire time, and then to move it forward to make it fully go through the hoop. Unfortunately, the reason that this is close but not fully working is because we probably need something like to a pause between here, because it wasn't actually fully turning clockwise 180. It would go if we just commented out clockwise 180 and just did forward 100, we got it to work perfectly. So another thing that we might look into in the future, if we have more time, is putting it as a backward 100 instead. Which also would be a very viable option. And then that would be all that we have for the actual hoops. I can show you the PyCharm code, which isn't going to be that far off from what you already saw. You can actually see here that it more or less just acts as the copy and paste of this. So you can see our first hoop is the exact same 5170, the go message, and our attempts at a yaw. So you can end up seeing all of this through here. So our main difficulties with this were just figuring out the syntax. It was really hard to be able to figure out parts of it, and although there were other people that could help us in showing what they brute forced until they figured it out, which was extremely nice, it got slightly tiresome by the curve point, because there was like one group who managed to figure out the curve and nobody else could ever figure it out or really come that far close. It was kind of difficult too. Some of the coordinates are really finicky, so it can be a little bit hard to get everything down. But in the end, it was still fairly simple, but also really nice, and it showed you more or less a direct result of your code. And it's also kind of interesting because you end up being able to see all of these functions that end up actually moving it, so that way it pushes it to this, and it actually just pushes it straight to the drones. That way it works, and not through a wired connection or anything, through just a wireless connection, which is really interesting. And it's really interesting to see all the variables individually that they put behind it. But overall, I really liked this project, and I thought it was extremely fun. I was kind of hard to figure out all of the little finicky bits, but at the end of the day, with the power of Google and brute forcing code until we got it to a position that we were happy with, it worked out lovely.